ESLint is one of the most popular packages ever and has been downloaded over 30 million times a week, and it's considered a must-have library for all projects. In this video, I will show you in depth how ESLint works by recreating the original project. I'll dive into how to analyze the JavaScript syntax and generate code from it. Instead of just adding semicolons or replacing quotes, I prepared a project to determine where users should use const or let declarations and generate a new file with all changes. Are you ready? Grab a drink and let's begin. ESLint is a tool to help you establish patterns on your code base, identifying and reporting problems. It reads your code as a string, sends it to spree, and parses it into an abstract syntax tree object. I released a video on this channel recreating Unveiling.js, where I minify code and generate source maps using the same approach. If you haven't seen that, don't worry, I'm gonna briefly explain what is an abstract syntax tree. An AST, or abstract syntax tree, is a representation of how your code is being interpreted by the JavaScript engine. It shows us when variables were created, when functions were declared, when an object was replaced, and much more. It's a map from your code string to an object to help you analyze and generate code if needed. The most common library for generating the JavaScript AST is Acorn. It's really straightforward to work with it, and it supports both CommonJS and ECMAScript modules. On the other hand, ESLint uses an abstraction for Acorn. They use spree, which is built on top of Acorn. If you take a look at the spree docs, they said they are extending Acorn because they don't rely only on the generated AST itself, but also on the concept of tokens. I chose to use spree just to follow the same approach the original project does, but in the end, for us, it's exactly the same thing. In summary, the AST is a detailed representation of a plain text code mapped into instances. Don't feel bad if those keywords are new to you. Usually, only people working on code analyzers know it, so it's very rare to see content out there about it. If you like this kind of content, you can support my work by subscribing this channel and leaving a comment on what you think about this mind science project. As this is the first content out there, remember to share it with your colleagues and discuss with them the magic we'll be doing today. The amazing thing about ESLint is that it's extensible and you'll implement plugins to establish your own patterns. For example, one popular JavaScript style guide, the Airbnb style guide. There, they define rules that must be followed in your code base, such as you cannot use var, use const or let instead. Or you shouldn't use string template literals if you're not binding variables. Use single quotes instead of double quotes, and much more. For our ESLint clone, I will implement both reporting and fixing code in the same project so you can understand the end-to-end of this tool. I've set up some requirements to see if our program will pass the evaluation, a real-world test to see if it works. Some rules for using let. Having a variable defined as var and is being reassigned, this should be transformed to let. Having a variable defined as let and it's being reassigned, this should be kept as let. Now for using const. Having a variable defined as var and never reassigned, this should be transformed into a const. Having a variable defined as let and never reassigned, this should be transformed into a const. And finally, having a variable defined as const and never reassigned, this should be kept as const. Now some rules for quotes. Our program should replace all double quotes with single quotes. And our program should be able to work on real-world use cases, should be able to lint and report errors from a real-world file. I know I could have defined a simple standard, like to add semicolons at the end of the line, but I wanted to bring a real challenge where you'd analyze the full structure and make complex logic on an AST. I'll use a JavaScript file as an example, but by the end of this video, you'll be able to run the program in whatever project you have and see results. How amazing is that, my friend? Let me show you the working project and what we implement with me during this video. Okay, I have this project, right? So I'm using let here for a variable that's never been assigned, right? So I have another variables here that never is being reassigned, but I'm using var, okay? This should be replaced by const. And I have other bad practices here where I should use let, and I have let for this, that which it's never been changed, okay? So you're gonna create a command, which is the ESLint clone, okay? So if I run this command, we're gonna ask for a file, so I can use file and pass through my own file, okay? Once I run this project, you're gonna see the full list of errors. So let's check this out. So if I click here, I can see right away which is the reference for this. So this function is never being changed, right? This variable, this value is never being changed. So use const instead of let. What if I see here, I can see that I'm using double quotes, const var for other variables as well, right? So here I can see this should be const. Well, what if I go here and change this, reassign the text, right? Because here it's saying it should be a const. If I try running again, you're gonna see that let is correct, so I don't see any error. But if I change here to var, I can see use let instead of var, right? And you're gonna see that we have now a new file, and this new file, it's gonna be changed as we fix the code, okay? So you're gonna see let here, but if I comment all their assignments here and try running again, you're gonna see that the final code is actually working fine, okay? So this is gonna be working in any project that you wanna analyze, okay? This is not just for my example code here, but for everything, my friend. Now is the time for action. You're gonna create a command line interface program where you'd run ESLint clone file and senior file. And this program will both report problems and generate a file with all problems fixed. Are you ready for this? Let's get started. All right, first of all, let me show you the version I'm using. So this is the currently Node.js LTS version, okay? So let's get started. I'm gonna initialize a Node.js project, right? So it's right there. And we can just set up all the properties we wanna have on our package.json file. So I'm gonna use npm package set. So I'm gonna use type modules, okay, to use ECMAScript modules. I'm gonna pass through engines.node, and I'm gonna pass through the current Node.js version I have, and I will set up the author name, so you can set up your own name, okay? If I run this, we're gonna see the changes on the package.json, okay? So here I have the Erick Wendel, type is in singular, type module, okay, not modules, and Erick Wendel. If you wanna change the project name, it usually goes on your application names, so you can go ESLint clone, okay? Nice. So, well, I'm gonna first create the error file, okay? And in this error file, we're gonna put a code with all bad practices we wanna lint in. So I'm gonna create first, let text, I don't know, ABC 1 2 3 plus, I don't know, CDE 1998, anything, okay? But remember, double quotes here, I'm using let. I'm gonna use var, never reassign it. I'm gonna just change this reference. I'm gonna put here Erick Wendel. You're gonna see some suggestions here because I'm using GitHub Copilot, okay? GitHub Copilot is gonna help us a lot today. I'm gonna be using more one here to be reassigned, and I'm gonna reassign this value, okay? So I'm gonna use name, and I'm gonna reassign it again, but differently. So name 1, just to see numbers changing and everything. And I'm gonna change again. So it was an object, now it's a value, and now it will come back again to an object. Just to see how messy this could be, okay? I'm gonna create let result, and I'm gonna navigate on split, on the text, right? Result is equal. So I'm gonna split by comma. I'm gonna grab all different letters and return the letter as uppercase, okay? Then I'm gonna join them all. Oh, here I should use double quotes so you can see problems. And I'm gonna join all of them in just a dot, okay? Just creating all messy so we can see this working. All right, let me move this a bit from here. If I try running this error should work, right? So we can see this crazy output, but this is for now. This is gonna be our base to start analyzing the code and replacing and generating another file for us. Okay, I'm gonna create a file, a folder actually, called src, and I'm gonna create the index file. Okay, this index file is gonna be our entry point to running all the application. As I was telling you, we're gonna analyze the syntax from this file using a library, exactly the same library ESLint is using behind the scenes. So let's install it. We're gonna install spree at 961. Okay, so this is gonna help us a lot to start working on our project. So the first thing I want to do here is grabbing the parameters from the command line interface so we can see and grab the file, okay? So I'm going to import from node.js the parse args, okay? I'm going to create get file path from CLI, and I'm going to use the parse args here. Okay, well, to create this, we should pass our options, which is the user could use -- file or just f. Okay, so I'm gonna call this file. I'm gonna say the type, it's gonna be string, and an alias is gonna be f. Okay, all set from this. We can then just grab the values from there. So I'm gonna grab values and the file itself, okay? Whatever you choose, file or f on the command line, you can grab the results, okay? So I'm gonna just return the file and we can analyze how it's done. So const file path, and I'm gonna just print it out. Let's run this. So node src, and let's see, a file could be our error.js, right? So I grab the error.js there. What if it's empty? Well, we have an error, right? This shouldn't be empty. But I noticed some bug here. If I don't pass anything at all, it just got through. Weird, right? So I will implement here a try catch just to make sure this file will never be empty, right? So if the file is not provided, we're gonna throw a new error. Okay, this doesn't need any text because we know that the user didn't pass anything. If we have anything here, we can use console.error. Okay, and look how nice is it. We can install something to print out our logs in a colored way. Okay, so let's install chalk in a version 5.30. So let's import chalk from chalk, and let's print out with an error, pretty beautiful. Chalk.red, it's gonna be error, please provide a file path as an argument. and then we kill the process. Okay, now if you try running again, we're gonna see the error. So we can use with F or minus F. If we provide just the file here without the command, we're gonna see the same errors, but when we have the file path, we're gonna see the project working. Okay, nice. So now we are grabbing from our command line interface, and notice we hadn't had to install anything to get those parameters. Node.js itself, it's okay with it. All right, I'm gonna import also from fs node fs, and I'm gonna read this file as a string. Okay, so const code, it's gonna be fs, exactly what Copilot told us. Okay, so we probably installed Esprit, right? So Esprit is here, so let's import it as well. So to import it, it's gonna be a bit different. So Esprit from Esprit, and we can see the result, right? Let's check this out. So const ast equals Esprit dot parse. Nice. ECMAScript version, it's fine. I want even the locations, I want all the paths there. I would also like to use source type as module, as we are working with ECMAScript module in this. Okay, nice. So this is gonna synchronously parse the object, and we can see the result. I'm gonna actually just using a JSON string file and see what we get from there. Ooh, we got a huge object, right? Crazy, isn't it? What I'm gonna do, I'm gonna grab this and send it to a JSON file so we can analyze it. So it's gonna go to ast.json. So now we have the file. Ooh, nice. So you see, the AST is just a representation saying where is the code. So if I try creating here, like we have the code here, right? What we have on the LUC is where it tells us where it starts. So line 1, column 4, line 1, column 4. So the color 4 is let, right? Well, we have identifiers. So start line 1, column 5, and ends on color 8. So something nice here is you can press Command P or Control P, and you can type it if you want. So column 1, line 1, column 8. So text is here. But notice something is in the middle of the X, right? Something I notice here is the column. We always add one more to it. So if it's 8, it will be actually 9. So on 9, we can go to the final declaration. Okay, this is something that we're gonna go on the text as well. But something I noticed, it's very hard to analyze this by ourselves, right? This is crazy, and we have to handle. There must be some other way to help us, right? Yes, you're right. So I'm gonna go now to a website called AST Explorer. Ooh. So grab your error code and let's paste there. Okay? So here, if you click on the declaration, it's gonna autofocus and show you what is there. So the kind is let, the declaration is something there. Well, we can see in this case, the declaration is kind of var, but when we are changing, we can see that the object is an expression statement, right? So here we have all what's happening in the language. We are just analyzing as the JavaScript engine would do. This is so crazy nice, right? You can just scroll up and scroll down and take a look of all the code. Nice. Going back to the code, you can close them all. And what we're gonna do? Well, as the index.js is working fine, now we're gonna transform it in a command line interface program. So you can use, as I did, just the command without having to run npm or install the package on your machine. Okay, so in the index.js file, we're gonna have to put here this command, which is called hashbang, right? And I'm gonna put it here, user.bing.env, which is the default place for Node.js on my machine, right? Probably for all Linux and our Linux-based program. So if I run from this, I can go there and see Node. Oh, actually, we can try checking this. Nice, without the hashbang, right? Just the path. I can see where Node.js is. But if I go try finding where is Node.js, you're gonna see it's a different side, right? But this is where Mac and Linux distributions are storing all the binary environment. Okay, so we put it there and it's all fine. All right, the second step is to transform this on an executable. So we are gonna use c8 mode plus x on our source index.js. Okay, now if you try listing what is on the src, you're gonna see it's red now. Okay, because this could be an executable. Perfect. On our package JSON, now we can have a bin. Okay, but I'm gonna define a custom command. Okay, it's exactly what GitHub Copilot suggested, but it's on src. Okay, nice. So what do we do now? All right, if you use npm link, you're gonna see now this command is gonna be available. If you run here ESLint clone, you can see exactly the same output you just created. You can pass through your file, which is gonna be the error, and we're gonna see the same output. Now you're gonna see this is linked, right? So if I remove the console log now, I can run just the ESLint clone, and it's exactly linked. Okay, even though I'm executing this command from the global machine, so we can see here ESLint clone, and we can see where it's being stored, right? It's not stored here from my file, but it's linked there. Okay, so I have on my Node.js environment and the ESLint clone. Nice. So now you can actually create here a linked minus file error JS, just to remember how to work this thing. Okay, nice. So if you want to remove this from your machine, you can run npm rm global and the name of the package, okay, as if it was a actual project. So now it's not available anymore. If you want to go back, npm link. Okay, and it's gonna be working fine. Perfect. We can remove now this and see the result. Now we're gonna try creating our report. Okay, so even though we haven't created any logic, we're gonna just create everything that we finish here is gonna be saved and replaced on a file. Okay, so to do this, I'm gonna install first the string, which is gonna be the code generator, right? From the AST, we're gonna use this library to output there. So in the version 1.8.6, and I'm gonna create the reporter. So the reporter is gonna be able to save a file or print out all the problems we're gonna see. Okay. All right. So I'm gonna create class reporter. I'm gonna create a static class report, and I'm gonna receive all the errors. I will need the AST to generate the final file and the output file path static, and we can export the full reporter. Okay, so in the index file we can import it. So reporter, remember to put .js, and in the end we have already the AST here. So I'm gonna need the output file, right? Const output file path. I'm gonna actually import one more module. path from node path. So I'm gonna have path.join, okay? Wherever you choose to run this command will be able to be executed anywhere on your machine, right? So I want to see the output on the current folder that you're executing this command. So I'm gonna get the current working directory, and I'm gonna grab the base name for this file, the file path, where is the directory. I'm gonna get the JS also, and I'm gonna add linted.js in the end, okay? Nice. So we have the file here, which is the full path, but the output is gonna be always whatever folder you started using this. So let's call the reporter.report. We're gonna have the errors, which we haven't played yet. We have the AST, and we have the output file path, okay? You can try running this just to make sure if it's working. We haven't seen any log. It's what we expect, okay? Well, for errors, I thought of something like this. I'm gonna have the message, let's say missing semicolon, and I'm gonna have also the error location. So the error location is gonna have our file path, and where is the location? Remember when I put this to go to the final file, to link on the file, so I'm gonna need like this, okay? File path, line, and column. Let's say column 3, okay. Nice. This is gonna be the format we're gonna be using, okay, for our errors. And let's implement the report first, and then we start working on the logic behind it. Okay, first I'm gonna run through the errors for each. Nice. Ooh. Copilot is suggesting a lot of stuff, but I'm gonna import chalk first. And then with chalk, what I'm gonna do, I'm gonna get const error message. It's gonna be chalk red, and we're gonna have error, okay? And then we're gonna also have the message. Then we're gonna have also the final message, which we're gonna link with all the location, right? So error message, and I'm gonna break a line. I'm gonna grab the chalk dot gray, which is the same color ESLint uses for this, and error location, okay? And then console.error with final message. Let's see if this works. So I'm gonna run it again. Chalk.read. It's red. Okay, let's see. Nice. If I click here, I can see that Visual Studio Code is going to the file, right? Exactly the line 1, column 3. This is what I expect for just our error here. Nice. We have this error. Now we should generate the final file, right? So const updated code. We're gonna need the string for this, and we're gonna use string dot generate, exactly the same idea we have there. I'm gonna also import here the fs from node.fs to write this file down, okay? Write file sync, the output path, and utf8 just in case. utf8. Okay, so if we don't have any errors, we're gonna console.log chalk green linting completed without errors. Okay, what else? We're gonna have a console.log with chalk red lint completed with how many errors? Oops. Errors.length error. Okay. What else? We can put the console.log here and say chalk green. It's gonna be code fixed and saved at, and then we can have a different color, so chalk yellow. So I'm gonna put here path base name, the output file path, and then I'm not sure if I imported path, not yet. Let's import path. Now it's there. What else? Well, just chalk green again successfully. Will this work? Let's check it out. Ooh, iString. Oh yeah, iString probably should be imported as. Let's see now. Well, now we have an error, right? With the linting error, and the code was fixed and saved at the linked.js. So if I click here, I can see exactly the same code. We don't have any changes there, but this is gonna be our first structure to fix everything out. All right, let's just make a different test here with no errors, right? Errors is gonna be empty. Let's see how is the output. Nice, completed without errors and fixed and saved in the same file. Perfect, perfect, perfect. Everything's working out. We also have the final file, which is exactly the same thing. But you're gonna notice when we're using a string, it removes the spaces, right? You can see it removed all the spaces and it just added semicolons, all right? So this formats a bit. If I have, let's say, some comments here, like text, 1, 2, 3. If I run this, you're gonna see now it's gonna be exactly the same thing, but if I comment this line, all comments will be removed, right? You cannot see any comments anymore. I'm gonna go through this step later, but let's just keep going, okay? So reporter, it's all fine. We can close it now. So I'm just closing, I can close this error. And now we're gonna start working on our syntax processor. So the same file, syntax tree processor.js, okay? And the same idea, export the full syntax tree processor. We'll export the full class, okay? And now I'm gonna have a process which is gonna receive the AST, okay? Nice. So on our index file, we should call this function. So it's gonna be const syntax tree processor. Syntax tree processor. I'm gonna grab all the errors from it. Oh, I can get later, okay? Well, to process this, we're gonna need the file path as well, okay? File path. So there, on their constructor, we're gonna get the file path. So file path is gonna be here. Now we're gonna go through all the ST, right? So for each line I have here in the body, we're gonna call this a node, right? A node declaration. So we're gonna go through this. And if you go here, what we want to see? We want to see those lines, right? Those lines here on the ST Explorer are literals, right? So we're gonna go on literals and we're gonna try finding these double quotes, okay? And then we can replace it by single quotes. So the type is literal, okay? This is what we're gonna try finding there. If you find here, you're gonna see a bunch of changes on literal, right? But this is what we wanna see there. Nice. So I'm gonna call it traverse. We're gonna use, I'm gonna call node because it's node declaration, right? For each thing of our AST, we're gonna go on different nodes. Okay, I can call this traverse with our AST. okay? And the full AST, we're gonna walk through there. So what I'm gonna do, I'm gonna define an object called hooks, and I'm gonna try finding what is the object I wanna find out. In this case, it's gonna be the literal, okay? And I'm gonna just keep as a function right here. And for each node declaration we have, I'm gonna execute on those hooks for all the properties or types we wanna try finding and executing. We're gonna execute from here. So how I'm gonna do this? I'm gonna execute hooks on the node dot type. Okay. So if you go to, I think it's better seeing here, the literal, right? But we're gonna see the type. So the type here is binary expression. Let's see if here it's better. So type literal. Okay, we have here the literal for this string. We will have other one for this string and other one for Anna. Okay, and exactly the same thing. We have one here. So we're gonna go on the nodes that have this type literal. So this means that we have some value there that is probably using double quotes. Okay, nice. So we're gonna have the type, but if this type is not mapped on our hooks, I'm gonna use an optional chaining, and I'm gonna call the node declaration, okay, and execute it. After it, we're gonna go through our node, exactly the same thing GitHub is proposing, but not this crazy stuff. So if type of the node declaration in key is different than an object, this means that it's the end of the tree, okay? So we just continue. Otherwise, we call the traverse again, okay? And then we can close our for. So this is gonna walk recursively into all those nodes and subnodes, right? And going on and on and on until we find everything we want. Nice. So now let's create a function to handle this literal, right? So I'm gonna call handle literal. So we're gonna have the node declaration, and if we can see here a raw, right? Raw, it's where the values are. So if this object doesn't have this raw, this means that we are in the wrong node. So if not node raw, and the type of the node.value should be string, then we return. Okay, so let's see, the value here is string. I think it's different than string, right? And this is node, I think I'm gonna call it, yeah, could be node declaration. So node declaration. Okay, so if this is the key is raw, and if the value is different than string, this means that we cannot replace anything, right? So we're gonna get the position, right? So we have here the LOC, and we know where's the line and the column. So const position, it's gonna be node LOC dot start, and we can go and do before actually. If the node raw doesn't include this double quotes, there's nothing to do, right? Node declaration. So we can return it right away. Okay, so if this is not a string and doesn't include the key we are trying to find, this means that it's all fine. Okay, otherwise we can just replace this node with it. So we're gonna say our node raw, it's gonna be node raw and replaced by a single quote. Just it, just it, my friend. What else? Now we can see the result. I'm gonna keep this because we can use it after it. So I'm gonna call this on our literal. So I'm gonna grab here the node, passing through the node. Okay, so processes here, we have the traverse, and if we calling from here, we have the syntax processor. We should just call process, right? And pass through the AST. Okay, so we have the full AST here, but I'm gonna say that I'm gonna return the errors. Okay, so errors is gonna be just an array for now. So errors is gonna be a map, and then I'm gonna return this errors dot values. Okay, so whatever we have errors, we can notify the users there. Oh, why we are using a map here, not an array? I'm gonna tell you later. Okay, so now this is gonna return the errors object, and we can just pass through here, right? So what are we doing? We are parsing the ST, we are sending to our processor, we are trying to find our double quotes, replacing it, and if there's any error, this is gonna notify all the errors for us and show it right away. So let's run and let's see the final example. So node is not defined, it's no declaration, right? And let's run again. Ooh, no errors, okay, because we haven't notified anything. What do we expect? All the double quotes should be single quotes. It didn't work well, right? Let's see what happened. Oh, yeah, I got the problem. See that I'm negating the thing here, right? So this should be if it's equal to string and we have a proper row, and I'm negating and returning, right? So if it didn't pass on this two, I'm negating and just returning, just making the reverse logic, right? Let's see. Ooh, nice. So all single quotes, and it's working fine. Just a matter of curiosity, you can try running this file, okay? This should be a valid JavaScript file, okay? Nice. So double quotes, single quotes, it's working fine. Let's implement now our error, right? How are we gonna store this error and notify the user? So I'm gonna create a function here called store error. I'm gonna grab the message, the line, and column, right? So, ooh, this is almost exactly what I wanted. Nice. So we have the file path, we have this command, we have line and column. But remember, I told you, we have to add +1 because it starts from 0. When we click on the link, we should add more 1 here. And we should just set our error. The error location, it's gonna be the error location, it's gonna be the key. Why I did this? Because sometimes we try replacing. Check this out. It was a var, right? First time we saw it was a var. We haven't found any reassignment. We changed it to const. But then at the end of the file, we noticed this actually should be changed to let because there's some reassignment. So probably we're gonna have two different messages, right? This way I'm making sure that I'm only gonna keep the last error message for that specific line and column, okay? So we can call and find a lot of different errors, but this way we're gonna have only the last ones. Nice. So now we have the position, the LOC here have the line and the column, right? So we have line and column, and then we should just store the message and call it right away. Something nice I'm gonna do here, it's standardizing the messages, right? So messages for single quote, it's gonna be a function, use single quotes instead of double quotes, okay? I can do for the others too, but I'm gonna let this way. Now I'm gonna call the store error So the message, single quote, and then we can have the position. Okay, the position should be, I think it's better just pass through, right? We don't need to store in any variable. Now, if I run this code, I should see the log here, right? So ESLint, we found a problem. Node, it's not node, it's no declaration, Eric, come on. Ooh, nice, isn't it? If we click here, we can see exactly the same line and column, right? Perfect. Check it out. This is because I added +1 to the column, right? And then you can see where are the errors. Woohoo! Nice, isn't it? Let's go to the second part of this video. Just a quick break now before we jump to the next chapter so you can relax a bit, okay? I recreated Node.js from scratch, and as this video, it's been pretty complex to finally make it work. I abstract all complexity and even created a cloud coding environment to help you. So I released an ebook, and it's the first content on the internet showing you how to understand what's behind the scenes of the Node.js core. There, you make your own Node.js runtime version from scratch, and I'll show you the relationship between Chrome V8 engine, libuv, and the C++ bridge. This will help you understand and troubleshoot current problems that your Node applications might have, such as bottlenecks, performance issues, and much more. Check the page in the video description to learn more about it. Also, follow me on Instagram, Twitter, and LinkedIn, and check out my website where I gather all the training courses I've launched. There's a lot of free content that can help you out. Give it a shot. Well, it turned out that replacing variable declarations were more complex than I thought. You have to watch for whenever an expression statement and variable declaration happen and store it in memory to perform operations later. An expression statement happens when someone is trying to change a value from an object or reassigning values to a declaration and make decisions. And variable declaration is whenever you have var, let, or const in the code. Let's recap the requirements for replacing variable definitions. So, rules for using let. Having a variable defined as var and it's being reassigned should be transformed to let. Having a variable defined as let and it's being reassigned, this should be kept as let. And some rules for using const. Having a variable defined as var and never reassigned should be transformed into a const. Having a variable defined as let and never reassigned should be transformed into a const. Having a variable defined as const and never reassigned, this should be kept as const. All right, let's jump to the demonstration then. All right, so let's go back again to check what we're gonna look for now. So if we click on the variables, you're gonna see the type here is the variable declaration, right? Every time we're gonna have them, we have variable declaration. So what I'm gonna do, I'm gonna store all those variables, okay? And check whether they are being used or whether they are being changed during the code, okay? So let's go to the code. Oh, something nice here is I'm using Esprit here, right? But you could have used Acorn and most of all other frameworks. They probably follow the same framework, but this is fine. Okay. So what we said there, we're gonna have now variable declaration. And then I'm gonna create the same idea, handle variable declaration. And I'm gonna create this new function right after handling literals. Oops. So I'm gonna receive the declaration and I'm gonna close it right away. Okay, so I'm gonna store all those variables. So I'm gonna just duplicate this and call it variables. So I'm gonna go through all the declarations we have here. So what we're gonna see, if I click here, I'm gonna see the declaration and we have an array, right? So the array usually contains only one node, but all of them have this array. So we're gonna go through all this and store some ideas from here. so we can try changing the kind. Okay, you can see kind here. Kind is what we want to change when changing the code. We won't use any replacer, right? This is just using the est. So once we change this kind to const, to var, or to let, the whole JavaScript code is gonna be changed. This is wonderful, my friend. So let's go through on this. Const. Ooh. And then because we wanna show on the logs that what was before, right? But remember I told you, sometimes we can have the same variable being changed. So I want you to store how it was previously, how it was declared, and then if we change this 10 times, I just wanna print out on the logs and report the original kind, okay? Const original kind, it's gonna be our declaration, actually no declaration dot kind. So it can be here, and I'm gonna just save on the variables. Ooh, so I wanna need more things. So I'm gonna need the original kind. I notice here I wanted to store some state, so we know how it's gonna be when we are in the declaration state or when we are actually reassign values. So I'm gonna also create here stages. So it's gonna be declaration, and we're gonna have expression declaration, which I'm gonna show you later, but we're gonna also have it here, okay? So declaration is when the application just declaring variables, and expression is when it's trying to change it, okay? So I'm gonna save this stage as stages declaration, and I'm gonna keep the reference for this declaration so I can change it later. So node declaration, it's gonna be our node declaration, just the object, okay? So this way I'm gonna have a different ID if I have a different name. I don't think we will have, let me see, it's because we don't have any ID here, right? The ID is only on the declaration, so we're gonna have the full node and we have only the declaration how it was started here. So I need the ID dot name to get to know what is the variable name. I don't think we have on the main declaration. We have just, yeah, okay. This is why we are grabbing the name, because the name it's only on its ID. Usually it's just the first, right? I'm gonna keep this way, but I don't know if you wanna get only the first declaration, and that's fine. What do I expect? Now I expect after traversing the whole thing, I wanna see the variables being stored there. So let's print out this console.log. No, I want to see variables. Variables.entries, so we can see keys and values. Okay, let's run it again. So now we can see the result. We can see to be assigned, never assigned, and text, right? If you go here and see like the length, how many? 4 variables. Let's count. We have 1, 2, 3, 4. Exactly what we want, okay? Nice. So you can remove the variables are being stored correctly. And now what we want to see? We want to see when someone is changing those variables. So if I click here, I can see that the node is an expression statement, right? We will have expression statements whenever someone is changing a value. This could be an object, this could be a primitive value, okay? It's always an expression statement. So let's go there and implement the expression statement. Exactly the same idea. We receive the node, handle, expression statement, and we're gonna create a function exactly the same idea. Now, if you go there, you can see the object is expression, right? But if you go to the last expression here, you're gonna see they are very different. So I was analyzing this code. This is because we are calling console.log, right? So console.log is also an expression statement, but it's a function call. So this is why we have a Kali here. But if you go on the others, you won't see this object. So what differ from one to another is this object, right? Left or right. When we have the console log, we don't have it. We don't have console. We don't have left or right. So let's go there and let's try implementing it. So const expression from node. And just to remember, console.log doesn't have it. So if expression, if it doesn't have a left, I'm gonna put a optional chaining type, and this must be different than, actually it must be an identifier. I'm gonna show you why. So if I go here, we can see the variable declaration here. We have the expression statement, the assignment expression, and we have left the member expression, right? So what I want here are the objects here that are identifiers, okay? So if they don't have this object, I don't want them. Same idea here. If I go there, I can see the literal, the assignment expression. If I go left, we have type identifier, exactly what I want, okay? So only identifiers, and then we can grab this function. So we can get the var name, which is gonna be the expression dot left dot object, and if this is undefined, I'm gonna grab the expression dot left, okay? And I'm gonna grab the name. So you can go through on the whole tree and checking for these values as well. Some of them doesn't have this object name, so some of them just have left, okay? Nice. So if this variable, for some reasons, are not on our variables map, this means that something is wrong, or someone created this value without defining with let or const. JavaScript, you can go here and just delete it, right? So if someone does that, it won't be on our variables. So we just return it right away. Otherwise, we already have this variable. So const variable, it's gonna be our variable from there, okay? From there, I'm gonna extract the node declaration and the original kind for our variable, okay? Perfect. What I'm gonna do now, I'm gonna try changing what it should be const, okay? So for const, if you are analyzing here, you can see what is the difference. So to be reassigned here, we're gonna have object expression, right? And it's an assignment expression, okay? But for an object, we're gonna see it's a member expression, okay? For const, we can actually change its value, but we cannot change, we cannot reassign, okay? So we're gonna look forward for the member expression. So if expression dot left dot type is our member expression, and we can get the stage from here also, and the stage is our declaration. This means that we never changed, right? This is the first time we are analyzing this. Once we change the state, we can try doing another stuff, okay? So I'm gonna just put here means changing an object property from a variable, so you know what we are doing here. Okay, the other thing I want to do is if already const, keep it, okay? So if the original kind is exactly we could put const, but let's make the good practice here, right? Variable types or kinds would be, it's gonna be const, const let and var. And then we can put on our if. So if it's variable kinds, if it's a const, we return. We just start processing because there is nothing to do. We don't need to change it, right? Someone got in the original file and wrote here const. It's already defined const. It's working well. We shouldn't do anything, okay? Because we are just handling in this case when we have changes for the object, okay? If you are trying to reassign, it's gonna be a different if. Okay, so someone is changing an object property and it's already a const, we shouldn't do anything anymore. Otherwise, we can store this error because we know something got wrong. So how do we store it? Let's create a message for use const. I'm gonna use here the variable kind, okay? And I'm gonna say, ooh, nice, use const instead of variable kind. I'm gonna just put the double quotes here, and we can do the same thing for let, right? Let and let. Perfect. So now we have the message. So the message will be messages use const, and the same idea, no declaration, LUC start, and then we can return it. Actually, we should save the states now, right? Because we are changing. This is probably a var or a let, so we should store this new value for this variable. So variables dot set var name, we're gonna grab all the variable we had and we're gonna replace it. So the stage, it's gonna be the new stage, which is the expression declaration, and we can keep the no declaration, okay? But we need to change it, right? So if we don't change the no declaration, nothing will happen. So the no declaration dot kind, it's gonna receive our variables kind dot const. Ooh, will this work? I don't know, but what we should see in the end, we should see our variables changing to const. I'm gonna save this file. So let's check this out and see if this is working. So let's see. Well, it seemed not to be working, right? We have a lot of vars. Well, I think there's an error on my if. So actually, if they're independently, if they are identifier or not, I just want to check if they have the left, okay? I was checking here on the AST. You can see that the type here for our left is identifier to be reassigned, but it's not always they were there, right? Let's check now. I'm gonna run and let's see. Ooh, we have const everywhere, right? Nice, isn't it? So it's working fine now. So we have const. So let's check if I comment here. If I comment here, let's see the result. Actually, we should see some error, right? Const instead of var, const instead of var. If you click here and here, nice, it's working fine. But you see that it's not order, right? Let's just check on our reporter to order results. So before the errors here, I'm gonna sort it. Oops. So our error, it's coming like error.js on line 19, column 9, right? So we want to split this into line 19 and column 9, right? So const a line a column. It's gonna be error1 dot error location, exactly what Copilot changed, right? So this is gonna be error2, and we're gonna compare. If they're equal, I'm gonna return a minus b, otherwise just them. Okay, let's check this out. I'm gonna run again, and now we see that it's order, right? 112, 123, 1 2 3, and const and var 5, exactly what we wanted. So let's keep going. Okay, if I remove this just to make a triple check, now we won't have text. All right, because we are working only on objects, right? Let's try doing for text as well. So we can remove this, just keep if there's no left, which is the console log, we just move away. Okay, for objects are okay. So what we want to do now, so if it's a let and it's already being assigned, this means that we should keep as it is, right? So if we have let here, we should keep this as it is. So if it's an object, someone's trying to change an object, this could be, so this is a const. So if not, means keeping the variable as it is, okay? So we're gonna check out on our node declaration dot kind and check if it's actually the original kind, and check if they are including on our variable kinds on let. Okay, and just remember to return right at the end. I'm gonna move this, I think it's better in the same line and here to make it easy to understand, right? Okay, this means that we can update our variables and set up our variable with the variables, actually the variable. The stage is now gonna change, right? Now stage declaration, and we pass through our node declaration, even though we haven't changed anything. Okay, so this means that if it hasn't let and haven't changed, we were doing anything else. So just run to check it out. So we have let, which should be okay, and this should be kept as let. Okay, nice. So it's being kept as let in this case. But see, text is not being changed to const, right? Even though we are not handling it, but we are doing this in a field. Okay, nice. Now the last one. So this means reassigning the variable. So now I'm gonna store the error. So if you are reassigning the variable and using var or const, this is almost impossible, but as we are just analyzing the code and not running, someone could put there as const as well, right? So use let and our node log start. Okay, now we're gonna change the kind to let, exactly what they did, and we're gonna update the variable. So we're gonna have the variable, we're gonna change the stage, we're gonna pass through the node declaration, and that's it. Okay, so what we would see now, we would see only if there's any assignments for const, we're gonna change it for const. Oops. Otherwise, it's already let. We're gonna keep as let because it's having reassignments, but let it's okay. Otherwise, it's changing reassigning values, but it's not let. We are changing and reporting errors from there. So there, let's see. I'm gonna put this as var. Okay, this should be reassigned, and just it. Let's see. Ooh, I wrote something wrong. It's return. Nice. So here, instead of const, const instead of var. Let's see, line 2, yeah, it's correct. And let instead of var. Very nice. Well, that's just one last thing for us to finish this class. I know it's been long, but we want to do also something for this line, right? So even though we are putting var or let here, as this is not being reassigned, we just assign once and we are not doing anything. See, if I change here and put as var, probably it's gonna be changed to let, right? So now it's let because we reassign it, okay? But if we don't reassign it all and let as let, we will see that there's nothing happening there because we are not checking, because this is not being replaced anymore, okay? So what I'm gonna do, after running all the things and after we start all the errors, I'm gonna check if there's any variable that needs to be checked, right? If any variable needs to be changed now after running down. Okay, so I'm gonna create a new function here, which we call check declarations. Oh, declarations that never changed. Okay, and I'm gonna call it right away after running all this traverse. All right, so I'm gonna run into our variables dot values, and I'm gonna filter them for stage, right? So I'm gonna have the stage and the node declaration from there, okay? Filter, yeah. So what I want the stage that is just in the declaration stage, which means that that's never went to our expression statement before, okay? So if they are on the declaration state and they are not already a const, right? Because this means that someone put it as var. So I'm gonna say, oh, Copilot is helping a lot, my friends. But I think I did some mistake here. Probably I wanna do this, put it here and put right here, right? Let's put this in the same line and here. So is it missing some breaking? So this should break in the last line. Nice. So it's a declaration state and it's not a const, okay? So we gonna for each it, new declaration, and then we know that we have to emit a message. This is very nice. Let's see if this will work. I think there is something missing. No, it's just here. So this means that this should be a const. We are sending the LUC and we are updating this const. Well, we should update the variables after it, but as this is the last step, we don't need to update the variables anymore. Let's check this out. So what I need this to be changed to const, right? And if it's a const, I'm gonna keep it as it is. So let's run again. Well, we have here use const instead of var, and here use const instead of let. So probably, yes, const is there, right? And for result, it's working fine as well. So let's make the last things to ensure that our project is working well, okay? Let's do some insurance here. So I'm gonna just move this right there. There it's here. And I'm gonna move right away, okay? So what I'm gonna do, if text is never being changed, this should be transformed to a const, right? So this we could see this is working fine, right? Nice. What if I reassign it with a value a bunch of times just to stress test it? I'm gonna see that test is actually let because it's being replaced, right? Nice. One test is okay. What if I transform this to var? So I have it as var, but I have some changes. If I run this, this should be kept as let. Nice, nice. What if I remove this text and save it? Well, the text will never be changed, right? So this should be transformed into a const. Woohoo! Nice! It's working fine as well. And if it's currently a const and we run it, this should be kept as const. Woohoo! It's working, it's working. Well, now let's try fixing all the problems and check if those messages will still be happening. So I'm gonna fix all the double quotes by single quotes. Now we will have only the variables, right? Just 3 arrows. Now never assigned. This is gonna be const. Now I have just 2. This is gonna be let. Now I have just 1, and I have const here. And I shouldn't see any problem, right? Nice. The last thing we want to do is checking on an actual project, right? Let's see if this works on an actual project. So I'm going to send the syntax tree processor, which I think won't have any problem. And let's see. So src syntax tree. When I do this, this is not going to replace our original file, right? We're going to have on our currently working directly. So I'm gonna run it. So we can see the hashbang is not working for private functions, right? But it seems on the index.js file I put 2020. It's 2022, the ECMAScript version. Let's check if this is gonna work. Nice. So it's working. I can see I would use single quotes instead of double quotes, but I wanna stress this. So I'm gonna go through all the consts that have a space, and I'm gonna change it by let, okay? And let's see how it goes. So I'm gonna run. We're gonna see a bunch of problems. So this run, if we click here, we can see the result. Well, we have a small problem here. That's gonna be probably a syntax error because we have the, let me see if I have here. We had something like this, right? So, oh, no, here. This is the original file. So we have a problem because we are replacing what we wanted from the string, right? So you probably wanna check out your code, but this seems to be okay. Let's see if we can run it on our reporter. So on our reporter, 2 errors we have here should be a sing one. If I run again, single quote, save it and run again. All set, all set. If you look at the code is valid, but you can see that just the spaces, break lines, and more were removed. But that's it, my friend. Amazing, isn't it? We are not done yet. Just before finishing it, I saw that we had a problem when we tried replacing double quotes by using regex, and that's why we never use regex when working with ASTs, okay? You should create the object for the AST and replace the node, not even using the node raw. This is why we saw some problem for syntax error when we output the whole thing. Okay, I've got some tasks for you to go further with this project. You may notice that when we're using a string to generate code, semicolons are being added automatically and line breaks, spaces, and comments are being removed. I brought tasks for you to implement on your own code. First, keep line breaks, keep comments, keep spaces, don't put semicolons automatically, and report missing semicolons. This way you can experiment and learn even more by implementing more features. This was fun, my friend. Thanks a lot for watching this video, and I hope you were able to accomplish the final project. Handling ASTs is the keys to building any developer tool and understand how crazy nice projects such as Webpack, TypeScript, Babel, ESLint, and other tools work behind the scenes. Please leave a comment on what you wanna see next on this channel and let me know what you thought about this class and what idea you had about it. I also put this video on a special playlist on recreating tags from scratch. You may wanna check it out. That's it for today. I hope this content has exceeded your expectations. I'm Erick Wendel and I'll see you in the next video. They use Esprit, which is built on... Está muito rápido. They use Esprit, which is built on top of Elcore. There, they define rules that must follow. Use const or let instead. No. I've set up some requirements to see if our program. I have set up some requirements so if our program. So some rules for using let. A variable defined as var. A variable defined as var. If a variable defined as var is being if a variable defined as var and no. And finally, having a variable defined and now some rules for quotes. This, and make a complex logic on an, And our program should work with real world, but I wanted to bring scratch my friend, and it's been pretty, even created a cloud computing environment to help you. So I released, and even created a cloud coding environment to help you out. So I released an ebook. So a variable declaration is whenever having a variable defined as let and it's being reassigned.